All right, so I thought we would just go through the homework for section 10.2. This first one, they give you the slope and the y-intercept of the regression equation. So what this is the equation of the linear regression line through a set of points. So if they give you a slope and a y-intercept, you can write the equation. The only other thing that this is about is picking the right symbols. X is X because it's based on the actual ratings that we have. The y hat, that is our approximation for y based on X. So that's the symbol choice that we have. They're not both hats. The X isn't a hat. They're not both regular. The y is the hat and the X is just plain X. And the symbol y hat represents the predicted value of price. So question 2, suppose that IQ scores were obtained for 20 randomly selected sets of siblings. The 20 pairs measured a mean of 99.38 and 99.4. I guess these are the different pairs of siblings. There's a correlation of 0.886, a p-value of 0, a y-hat of negative 12.34 plus 1.12x, where x is the IQ score of the younger child. Find the best predicted value y-hat given that the younger child has an IQ of 94. Use a significance level of 0.05. So this is significant, this correlation, because our significance level is 0.05 and our p-value is 0. So we're in good shape for that. And if you looked at the correlation here, we have 20 pairs and our 0.88 is way above the 0.44, 0.561. We would need to have a significant correlation. So we want to use the model to do this prediction. So basically what you would do is take the 94 and plug it in for x right here in this equation, and that's how you would get this 92.94. Now on a similar question, hold on just a second. I know that, well, maybe not. Okay, I think they're all going to work out that way where you use the model. Yep. All right. Question 3, use the given data. Basically, if you, I had seen another one of these, if you can't use the model because it's not significant, if this p-value was too high or the correlation was too low, which will turn out to be the same, then you just use the mean as your approximation for the y hat. All right, question 3. Use the given data to find the equation of the regression line. Well, this is a place where we can go to StatCrunch. Just click the button, go to StatCrunch, do stats. Where did we find this the other day? Regression, simple linear. We're doing x variable, y variable. And we'll just let it go here. And you can see you get, whoa, got to bring it back. Oh my gosh. You can see that you get negative 0.37 plus 0.7x. That's done. You can also see the R values, this 0.816 with the sample size of 11. We don't need that on this question, but there it is. We can see the actual graph. So as we're picking our charts here, we can see the actual chart. It looks like that one over there in A. And then the thing that our linear regression line doesn't tell us that our scatter plot does is that the data has a pattern that is not a straight line. This seems to fit like part of a parabola. So that's what we learned from looking at the scatter plot. Question 4 is a similar deal. You can click this, pop open StatCrunch, immediately go to Stat, Regression, Simple Linear, X and Y, compute. You get this time 3.11 and 0.51 or 0.507 depending on how many decimal places they want. This says 2 decimal places, which I find a little weird. Oh, 3 decimal places on the coefficient, I see. So you got to pay attention to their rules here. And then if you look at the chart, you can pick the right chart. It's kind of linear here, but then there's a 1 point way off up at the top, which you can see goes along with graph C. And what you don't know from just having the numbers of the model is that there is 1 point that's really affecting the regression line, because the fact that this point's way up here significantly moved that regression line so that all the rest of them are below it. So if that point wasn't there, the line would have a lesser slope for sure. All right, that's all we're going to get done on regression.